Manufacturers have been spending much time, energy, and effort in treating wastewater. At the same time, pollution has been thriving all over the country, not just our country, but all over the world. But who could have thought that the answer would be thriving all along, even before human existence? Algae, one of the oldest microorganisms, sets a new flag for the sustainability of water on Earth. This would be the focal point of our report entitled Immobilization of Bacterial and Algal Systems for Wastewater Treatment. Hope you learned something and enjoy.
Primarily, algae can thrive in high salinity. And the first thing I will be sharing is that together with sand removing inorganic nitrogen, transforming it into something algae can take up. Algae stores contaminants such as organic nitrates using it as proteins for photosynthesis, which allows it to increase its concentration and culture ponds in wastewater treatments. It just needs sunlight, carbon dioxide, and wastewater, and that's all what it needs to consume pollutants to grow. Second is that it transforms carbon dioxide into oxygen gas from wastewater, which helps in recycling. Furthermore, algae grows fast. Thus, instead of becoming an environmental hazard, the nutrient-rich wastewater is bioremediated into clean water, an abundant biomass that can be used for cosmetic products, food, feeds, fertilizers, and fuel.
To further understand, let's discuss the basics of wastewater with algae. The process is called immobilization. It is a tool for bioremediation, and according to Peter K. Robinson, immobilization may be defined as the accumulation of a biocatalyst, cell or enzyme, either on surfaces or within particles. Therefore, yung fundamental characteristic ng immobilized system is that biocatalyst is fixed within a distinct phase. Ito yung biocatalyst phase, which is separate from the bulk phase, kung saan yung substrate and products are dissolved. Next, this system heterogeneity na give rise to two major advantages of immobilized systems over their non-immobilized counterparts. First is a physical advantage, kung saan yung biocatalyst and product may be separated easily, enabling effective product recovery and biocatalyst reuse. Then the biological advantage, in that the immobilized biocatalyst is often found to be more stable than the non-immobilized form. Yung sinasabi na stability ay yung enhanced rate ng catalysis, prolonged duration ng catalysis, or greater operational stability to extreme pH or temperature. Sinabi rin ni Peter K. Robinson na even in cases where there is no real biological advantage conferred by immobilization, the physical advantage of ease of separation of biocatalyst from product may be sufficient to favor implementation of an immobilized system in a variety of industrial situations. Yung mga systems na to usually develop to place the biocatalyst in a continuous flow reactor of the continuous flow stir tank or packed bed type where the catalyst is continuously being reused. Ideally, the immobilized microbial cell carrier should have the following characteristics. According to Kaidong, Bing, and Huan in Immobilized Microorganism Technology and its Application, there is no poison affection on microbial cells. It has good mass transfer, air permeability, and transmittance. It will be stable and not easy to decompose by microorganism, and it has high mechanical strength, long service life, and low cost. Sa ngayon, yung commonly used carriers can be divided into three kinds: organic, inorganic, and composite carrier. Inorganic carrier has porous glass, diatomite, activated carbon, and quartz sand. While organic carrier can also be divided into two categories. One is the polymer gel carrier, such as agar calcium alginate, and the other one is polymer gel carrier of organic synthesis, such as polyvinyl alcohol gel, light hardening resin, and polypropylene acid gel. The composite carrier is a combination of inorganic and organic materials, so that the performance of the two types of materials are complementary, which shows the superiority of the composite materials.
I will be discussing the process of immobilization. For the preparation of the process of immobilization, there are two methods. First is the adsorption methods, and the second is the embedding method. The adsorption method is one of the earliest and most widely used methods in treatment of wastewater. It includes two kinds of method, which are the physical adsorption and ionic adsorption. In physical adsorption, gumagamit dito ng high capacity of silica gel, activated carbon, and other adsorbent to immobilize microbial adsorption to the surface. As you can see in the screen, there is a wastewater in a reactor, and it uses activated carbon to remove the organic compound present in the wastewater. Next is the ionic adsorption. Ionic adsorption is based on the microorganism of disassociated state. Due to the electrostatic attraction, it immobilizes different charge of ion exchange agent. Embedding method is make the cell intersect in insoluble polymer gel core network space by polymerization, deposition, or ion exchange form, or by the change the solvent temperature or pH to make the cell intersect. So yung polymer gel network, pinaprevent niya na mag-leak yung cells and allow the substrate to penetrate and the production to spread out. This method can be divided into polymer synthesis embedding, ionic exchange embedding, and precipitation embedding. This method is simple at may konti lang siyang effect to microbial activity, which can be locked in specific polymer networks. And itong method na to ay mostly common na ginagamit to prepare immobilized microorganism. So, embedding method, adsorption method, ito yung pinag-aaralan at pinakang ginagamit in all kinds of immobilized microorganism. And meron din namang ibang kinds of methods, pero kailangan pa silang i-explore at ipag-aralan. For the application of wastewater treatments, let's talk about the treatment of refractory organic wastewater. Gumagamit dito ng conventional biological treatment methods, which consists of combination of physical, chemical, and biological process and operation to use to remove solids, organic matters, and sometimes nutrients from wastewater. It is a general term used to describe different degree of treatments. However, in this method, they have lower efficiency in treating wastewater containing refractory organic compounds such as phenols, aniline, DDT, and etc. This is because these microorganisms have longer growth period, and they are difficult to exist in conventional biological treatment structures. So, yung paggamit ng immobilized microbial technology can be used to select dominant bacteria and then fix it to the carrier para increase yung higher concentration ng microorganism, and then we can effectively deal with this kind of refractory organics. Now, for the treatment of wastewater containing heavy metal ions, so after immobilization, the stability increase and the removal of heavy metal ions can be used to treat organic wastewater. The absorption of heavy metal ions by algae has been extensively studied in the past decades, and the metal uptake by the algal cells has a complex process. So, the algae has yung algae kasi meron siyang strong ability to enrich the metal ions, and it can be used as a biological adsorption of toxic and radioactive metals and rare recycling metals by industrial waters. So, algae is efficient and economically and simple to use in this treatment of wastewater.
Good morning, everyone. I am Mary Joyce Martir, and I will report about studies on immobilized algal physiology and biochemistry. This is based on the study of Wong and Tam regarding the wastewater treatment with algae. This involved the use of eukaryotic green microalga or the Chlorella emersoni. Additionally, gumagamit din sila ng alginate entrapment as an immobilization technique based on the protocol of Kirsten and Bach by using 5% weight per volume of sodium alginate and 0.3 molar mass of calcium chloride para makapag-produce ng 4 mm diameter ng beads. Para ma-evaluate naman ang cell growth in the immobilized state, i-distrap yung beads gamit ang trisodium citrate at a pH of 6.5 at gagamitin ng Coulter counter para pilangin ang mga release cells. Here is the 20-day batch culture studies. Notice that yung growth rate ng cells na naka-entrap within alginate beads ay significantly na mas mababa kaysa sa free cell suspensions. However, the alginate entrap system suffered from considerable levels of cell leakage, with cells breaking out mula sa alginate beads and then growing rapidly within the bulk phase. This makes a real comparison of growth rate in the free and immobilized systems more complex. Analysis of growth rate in the immobilized state is further complicated by the fact that cells at the periphery of alginate beads had growth rates clearly greater than those within the center, leading to zonation of the cells such that only the outer 50 micrometer was used by the actively growing algae. Ito ang dalawang problema sa peripheral growth at cell leakage na pwedeng mag-cause na major limitations na use ng gel immobilized algal systems in a variety of biotechnological applications. Since ang mga algal cells are generally cultured autotrophically or photoheterotrophically, the necessity for illumination is clear and light limitation is usually perceived bilang major problem sa immobilized algal systems. In the study, alginate is a relatively transparent material na nakapag-allow ng good light penetration, at kapag ang mga immobilized and free cells ay nabigyan ng illumination within the chamber of an oxygen electrode, both types ng cells ay may similar response in bicarbonate-dependent oxygen evolution when irradiance was varied. Findings revealed that cells still grew at the periphery of the beads even when illumination was provided from the interior of the bead. Hindi importanteng limiting factor ang light or illumination dito sa batch culture, kundi ang carbon supply. However, sa paramount importance. Kapag ang bulk phase ng carbon dioxide concentration was elevated by bubbling, the culture with air enriched with 2% volume per volume carbon dioxide, mas magiging uniform ang cell growth throughout the bead volume. Similar results could be produced by culturing cells in an organic medium plus 0.1% ng weight per volume glucose, or even by co-immobilizing algal cells with urease and by adding urea to the bulk phase, thereby generating carbon dioxide within the bead itself. There are two main factors affect leakage of cells from alginate matrices. Una ay ang physical integrity of the gel itself, at pangalawa, the growth rate and location of the cells within the gel. Decreased bead disruption has been noted with the reduced pH and with alginates having high hyaluronic acid and mannuronic acid ratio. Leakage from immobilized systems ay nare-reduce din kapag ang growth ay hindi restricted to the periphery of the particle at kapag ang growth rate ay mabagal. Wrapping alginate beads in further layers of alginate to prevent cell leakage has been attempted with some success, pero ito ay impractical sa mga large-scale applications. Alginate is of course not the only naturally occurring gel which may be utilized for entrapment purposes. There are agar, agarose, carrageenan, and chitosan have all been used with some success. Here's the other list of immobilization techniques depending on the desired result. However, in the vast majority of these cases, long-term bead instability or cell leakage are also problems. Small degrees of cell leakage may not pose a problem for many applications of immobilized cells and may in fact contribute significantly to reactor performance. And that will be all. Thank you.
Let us now discuss the advantages and disadvantages of this environmental treatment technology. According to a study entitled The Application of Immobilized Microorganism Technology in Wastewater Treatment by Zhang in the year 2015, compared with other environmental treatment technology, the immobilized microbial technology has the following characteristics. So, number 1. Microbial immobilization can maintain the high concentration and activity of microorganisms in the reactor. So this can improve the processing load and removal efficiency of pollutants. This could also improve the general performance of the wastewater treatment facility. So having the average treatment efficiency increased by a large margin, it is beneficial to those treatment facilities who receive such amount of wastewater to be treated. Number 2. So by using the technology of immobilized microorganism technology, the sludge production is lower, and the burden of subsequent sludge disposal is reduced. As we all know, sludges are semi-solid slurries produced in many industrial processes such as wastewater treatment. So these sludges are a major factor in the design and operation of all wastewater treatment plants. So having sludge production to be low is a major advantage for any wastewater treatment plant since not only does it take a major part in the operations of a plant, its disposal is also proving to be difficult. So two of the basic goals of treating sludge before final disposal are to reduce its risk and to stabilize the organic material. That is to reduce the risk of being the source of a health hazard. So number 3, microbial immobilization have a strong ability and stability to toxic substances. Therefore, in the environmental pollution control, the immobilized microbial technology is to carry out extensive research and in-depth discussion. So other than wastewater treatment, it could also be used in other industrial processes such as sanitation, sewage system, or etc. if proven effective in further researches. So number 4, microbial immobilization is formed by the particle state, which is conducive to the separation of the sludge process. So due to this, it is easier for the sludge to be separated. And lastly, number 5, it will have some industry wastewater which can be effectively treated by microbial immobilization. So now let's go to the disadvantages. So immobilized microorganism technology in wastewater treatment and any other field has shown a great merit. It has aroused widespread concern and conducted a wide range of research and application. At the same time, we should also see that to achieve the industrialization of immobilized microbial technology, there are still many problems that needed to be further studied and solved. So number 1, the cost and service life of fixed carrier are the key factors to determine the economic feasibility of it. Therefore, how to make the suitable development of high-efficient biochemical reactor and low-cost immobilized microbial carrier for immobilized microbial cells and how to improve the service life of the carrier needed to be resolved. So number 2, immobilized microbial cells in the process of wastewater treatment may be ineffective for some suspended substances or polymer materials. It may also occur swollen up or clogging phenomena such as bugs. So we need to carry out the appropriate physical chemical treatment or with other processes play the respective advantages to achieve the best treatment effect. So number 3, study on the biological non-destructive high efficiency of the desorption agent. So it is believed that through continuous research and improvement, immobilized microbial technology will become an effective and practical technology for wastewater treatment to obtain a wide range of applications. So lastly, For many factors affecting the fixed operation, we need to select the best activity of immobilized cells to study on the optimal parameters of different immobilization methods and different carriers, which is the key to the wide application of the technology. So that is all for the report of Group 2. Thank you and God bless.